or my kids need to stop taking it. One or the other. All right, so let's take a look at question 22.26a. So we want to take nitrobenzene, and then we want to make this 1,3-dibromo benzene. And if you think about bromine, well, bromine is an ortho-para-director, and so there's no way to just brominate and then brominate again. You won't get this. And so I think but the nitro group is a meta-director, and so we could brominate that, right? So if we brominate the nitrobenzene, so what I mean is this. If we treat this with bromine and iron 3 bromide as our catalyst, we do end up with the bromine installed in the meta position to the nitro, okay, like this, okay? And then we can use Sandmeyer chemistry to convert the nitro into a bromine. So if you're not sure about what I mean here, let me just show you. So the first thing we have to do is we have to reduce the nitro down to an amine. And there's a few different ways we can do that. I chose to just use iron and aqueous acid, but that would give you the aniline ion. So you have to treat that with sodium hydroxide as a workup, and that's going to give you the aniline, right? You get the aniline like this, and then we can diazotize, right? So if we do a diazotization using sodium nitrite and HCl, that's going to give us, and hopefully I can squeeze it in here, okay, you're going to end up with the diazonium salt. So we put N2 plus and then Cl minus. And then to convert that to the bromine, you just have to do a Sandmeyer. So this is a Sandmeyer reaction. And so for that, we're going to use copper 1 bromide. And we're done like that. So there you go. So that involves a diazotization. So this is a diazotization reaction. And then it also involves a Sandmeyer reaction. All right, and a little bit of electrophilic aromatic substitution as well, right? You have to understand chapter 18 in order to understand that this is a meta-director, and you're going to put that bromine in the right position. Okay, let's take a look at B. So this is 22.26B, and in this one, our starting material is just plain old benzene. So if we're starting it with just some benzene, and then we want to make this phenol. So we have 1, 2, 3 carbons. So we have 3 propyl phenol. So we want to put in a propyl group. And a propyl group is an ortho-para-director. And phenol, or the hydroxyl, is an ortho-para-director as well. And we don't really have any ways to make a phenol except from the diazonium ion. So if we have aryl diazonium, so don't worry about the rest of it. But if we have that in place, all we have to do is put it in water and heat it up, and that's going to give us a phenol. But of course, we have to make this from the amine, right? So you kind of see where we're going here, okay? So now we have, and you know the amine has to come from the nitro. So you know that we've got to have the nitro group, and then we've also got to have that propyl group, but we know we can't just install a plain old propyl group via Friedel-Crafts because we're going to get rearrangement. So we'd end up with a mix of propyl and isopropyl. So we're going to have to do a Friedel-Crafts acylation. So the question becomes, do we put in the acyl group first or the nitro group first? I would put in the acyl group first because it's a meta-director and it's less deactivating than a nitro group. So I'll show you what I mean. So first I'm going to do a Friedel-Crafts acylation. So we're going to use propionyl chloride and aluminum chloride, and this does our Friedel-Crafts acylation. So we're going to install our acyl group like this, okay? And keep in mind, that's a meta-director, so we don't have to worry about reducing that right away. Now we're going to do the nitration. So we're going to treat that with nitric acid and sulfuric acid. And now that really sets the stage to get to the end of the synthesis. So now we have these 3 carbons in place, and we have our nitro group in place. So what should we reduce first? Well, it doesn't matter. Now, I looked in the textbook, and it says that if we do a Clemmensen reduction, that it's going to reduce the nitro group as well. If you did them both separately, it's totally fine. But you know that there's so many different ways to reduce a nitro group. It usually just involves a metal and some hydrochloric acid. So I'm just going to do a Clemmensen reduction, which is the zinc mercury amalgam, zinc mercury amalgam in HCl. and we heat that up. So that's a Clemmensen reduction. And like I said, that's going to reduce both. So we're going to reduce the nitro to the amine and the carbonyl. It's going to reduce that as well. Okay, so now all we have to do is diazotize. So to do that, we're going to treat the compound with sodium nitrite and HCl, and that gives us the diazonium ion. I'm kind of running out of space here. These are long syntheses. So now I have the diazonium ion, and so for the last step, all I have to do is treat it with water and heat it up. All right, so a little bit of chapter 18 in this problem and a little bit of chapter 22 as well. Okay, let's try the last one, which is 22.26c. So let me just scribble it down here. So this is 22.26c. And in this one, we're starting it with benzene again. So we're starting it with just some benzene, and we want to convert that into para-tert-butyl benzoic acid. So this compound here, there's our tert-butyl, and there's our benzoic acid. But like I told you before I started recording this, there's a couple of ways you could do this synthesis. There's a couple of ways you could do this, but I think that since we're in chapter 22, what we should do is we should make this from the nitrile. We should use Sandmeyer chemistry, so meaning we should have this. And so to make this compound, before we can do the Sandmeyer reaction, we're going to have to diazotize. So that means we're going to have the nitro group installed in there, and then we're going to reduce it, and then we're going to diazotize. So obviously we've got to put the tert-butyl in first, and then the nitro second. So to install the tert-butyl, we're just going to use some Friedel-Crafts chemistry for that. So we'll use tert-butyl chloride, aluminum chloride, and that's going to put our tert-butyl group in like this. Then to install the nitro, we just need nitric acid and sulfuric acid. It's almost like these questions are a little heavier on the chapter 18 than the chapter 22. So now we've got our nitro group. So now I'm going to put two steps in one here. So I'm going to do the reduction. So for that, I'm just going to use iron and acid, and we'll heat that up, and then we have to do a workup with sodium hydroxide. So that would give you the aniline. And after that, I'm going to put another step in here. We're going to diazotize. So sodium nitrite, come on, and HCl, like that. And that's going to give you the diazonium ion. So now we're ready for our Sandmeyer chemistry. So we end up with the salt, like that. I'm really running out of space on these. So now we're going to use copper cyanide to make the nitrile, which is going to look like this. And then to hydrolyze it to the carboxylic acid, we just use acid and heat. Anyhow, I'm trying to keep it all on the same screen, so I'm taking up too much space here. But anyhow, hopefully you'll follow me on that. And again, this reaction here, this is the Sandmeyer reaction. Sandmeyer reaction.